Dear students, I am going to read the question. Three blocks are connected as shown in the figure on a horizontal frictionless table. If M1 is equal to 1 kg, M2 is equal to 8 kg, M3 is equal to 27 kg and T3 is equal to 36 Newton, then what is the value of T2? Now first I am going to find out A net. A net is equal to F net upon M net, right? So A net is equal to, F net is how much, my dear? F net is equal to 36 Newton and M net is equal to, here is given 1 plus 8 plus 27, that is equal to 36 upon 36. So the acceleration will come as an 1 meter per second square. Understand? Now I am going to draw the free body diagram to finding out the tension. Okay, so from here, see the first block, it is the first block and is connected to second block. Okay, now this block is an 8 kg and this is an 1 kg block. Now here we have to find out the tension, that is an T2. So T2 will pull for the two blocks. So tension T2 is equal to 1 plus 8, right, into acceleration. So that is equal to, T2 is equal to 9 into 1, so 9 Newton. Okay, so what is the value will come? T2 is equal to 9 Newton. Understand? In the similar manner, if you want to find out T1 also we can able to find out. Actually the answer is 9 Newtons. Now we can also find out the T1. So T1 is equal to, so if you draw the free body diagram, there is only one block is there, 1 kg block. So here the tension is an T1. So T1 is equal to mass into acceleration. Mass is an 1 kg and 1 is an acceleration. So total is an 1 Newton. So T1 is equal to 1 Newton. So T1, T2 both we find out here. I am going to read the question. In the figure 3.144 given below, two masses M and M dash are tied with the thread passing over a pulley. M dash is on frictionless horizontal surface. If the acceleration due to gravity is g, in this arrangement will be. Okay, so now, so here I am going to be, see here A net, finding out the A net. A net is equal to, we know very well, F net upon M net, right? So now A net is equal to how much F net? Only mg will going to act downwards. So mg upon M net is equal to small m plus M dash. Understand? So this is only the value. So he asked what is the acceleration. So A net is equal to mg by M plus M dash. Okay. So second option is an correct option. Hope you understand. Dear student, this is an comprehension type questions. So actually he asked the free body diagrams in the 13th question. So just I am going to draw the free body diagram from the given diagram. So this is an M1. So upward is an T and downward is an M1G. So here the acceleration is an upward direction. Okay, because M2 is greater than M1. So tension T is equal to M1G, that is equal to M1A. So actually the free body diagram is first option is a correct option. Okay, so now for the 14th question, the free body diagram of M2 block. So here is an M2. M2 is greater than, so upward is an T, downward is an M2G. So now acceleration is in downward direction. So equation will come as an M2G minus T is equal to M2A. Okay, so here the diagram is second option is an correct answer. Understand? Now the 15th question, the acceleration of a, see here we have to find out the acceleration. So acceleration equation we have to find out. So 15th question, first acceleration we know that A net is equal to F net upon M net. right? So F net is equal to how much? M2G. So here is given the condition is an M2 is greater than M1, right? So in the above diagram, A net is equal to F net is how much, my dear? M2 minus M1 into G, otherwise M2G minus M1G upon M net is equal to M1 plus M2, right? So if we take a G common, so A net is equal to M2 minus M1 upon M1 plus M2 into G. So this is the answer, A net. Do you understand? So it is very easy, no need to worry about it. Okay, here is an second option is an correct answer, right? So this is an A net. So second option is an correct option. Hope you understand, my dear students. Okay, my dear students, I am going to read the question. The block is placed in the frictionless surface in a gravity-free space. A heavy string of a mass small m is connected and the force F is applied on the string. Then the tension at the middle of the rope is. So here we have to find out the tension at the middle of the rope. Okay, so for that I am going to be draw the free body diagram. So this is an block, this block mass is an capital M, and now this is an rope. Now so here the force is also acting F. Now here he says that to find out the tension at the middle of the rope. So rope mass is an M, so middle of the rope is nothing but it is an M by 2, M by 2. Yes or no? So total mass is M. Now we have to find out. See here, A net is equal to F net upon M net. Yes or no? F net is how much, my dear? Only F is acting. So F upon capital M plus small m. So this is an A net. Now we have to find out the tension at the middle of the rope. So free body diagram is, this is an capital M, mass of the block, it is an M by 2 is an rope. So now tension is nothing but here T is equal to, so mass into acceleration, mass is an capital M plus small m by 2 into A. So now we already find out the A value. So m plus small m by 2, A value is an capital F upon capital M plus small m. Understand? So now if you simplify this equation, T is equal to, it will come as an small m by 2 plus capital M, right, upon, here F is there, so capital F upon small m plus capital M. So this is the required answer. So our correct option is an second option. Okay, second, no, it is an first option. Hope you understand that. My dear students, I am going to read the question. A body of mass m is being pulled by a string of mass m with a force P applied at the one end. The force exerted by the string on the body will be. Okay, same as a similar question as we already done it. So I am going to draw the free body diagram. So this is an capital M of a block. Now see here, this is an string. Now here the force is an P. So A net is equal to F net upon M net. So F net upon M net, that is equal to P upon small m plus capital M. Okay, now so capital M, see here we have to find out the tension. So tension T is equal to M into A. So capital M into A. A value we already find out, so we have to substitute here capital M into P upon small m plus capital M. That is the answer. So our correct second option is the correct option. Okay, hope you understand. My dear students, I am going to read the question. Three equal masses A, B and C are pulled with a constant force F. They are connected to each other with a string. The ratio of the tensions between AB and BC is. Okay. So he has the ratios. So we will going to find out here now. So here let it be consider this is an T1 and here is an T2. Now first we find out the mass of each block. They already given as an right. The mass of each block is small m, right. Now A net is equal to F net upon M net. So how much force is acting? He already given as an F upon M net is an 3 blocks are there, right. So small m plus small m plus small m, that is equal to F upon 3m. So this is an A net. Now we have to find out the T1 and T2. So I am going to draw the free body diagram. So there are 2 blocks are there. Now let it be find out the T1 first. So this is an M, this is also M. Now T is equal to MA. So T1 is equal to M. How many masses are there? 2 masses. That's why 2M into A. A we already find out. Substitute the value. F by 3M. MM get cancelled here. The T1 value will come as an 2 by 3F. Yes or no? 2 by 3F. So this is the T1. Now I am going to find out the T2 value. So free body diagram. So only one block is there. So this mass is an small m. So now T2 is equal to MA. So T2 is equal to M, only one block. So M into A. A value is an F upon 3M. So MM get cancelled. T2 value is comes as an F upon 3. Right. So now we have to find out the ratios. So I am going to find out the ratio now. T1 upon T2. Okay. See here. T1 upon T2 is equal to 2F upon 3. So I will take the reciprocal here. So 3 upon F. F get cancelled. 3 get cancelled. Now T1 upon T2 is equal to 2 upon 1. Right. So that means to say that T1 is to T2 is equal to 2 is to 1. So that is our answer. Okay. So here is an second option is a correct option. Hope you understand. My dear students, I am going to read the question. 2 masses M1 and M2 are attached to the spring balance S as shown in the figure. If M1 is greater than M2, then the reading of the spring balance will be. Okay, we have to find out the reading of the spring balance. Okay. Now reading of the spring balance is nothing but it is a tension. Okay. So tension of the string. Understand? So if you find out the tension, that only the reading. Tension may be any tension, T1 or T2, anything will give the same answer. Okay, that means so the reading will be T1 by G or T2 upon G. Yes or no? So reading will always give by T1 by G. Right? So here first we are going to find out the F net. F net is equal to, A net is equal to F net upon M net. So F net is equal to how much, my dear? Their condition is given. Right. So M1 is greater than M2. So that is why acceleration will be an M2 direction. So m2 minus m1 into g upon m1 plus m2. So that is a net, right? Many times we did this. Okay, need not to be worried. So now we are going to find out the tension T1 or T2. See here now, anything we can find out, no need to worry about it. If you want, we can find out both the things. Okay, don't worry, both will be give the same answer. Okay, so both will give the same reading. See here now. So first I will going to be find out the tension T1. I'll draw the free body diagram. So this is an m1g and mass is an m1. Tension will act upward and acceleration will act downward because m1 is greater. So now m1g minus t is equal to m1a. Understand? So substitute the value. T1 is equal to m1, right? So here I will going to take the common, otherwise if you want I can write m1g minus m1a. So now m1g, okay, otherwise we will take a common as an m1. So remaining is in g minus a values we already find out, m1 minus m2 upon m1 plus m2 into g, right? Here g also we can take common. So in the next step I will take the common. So T1 is equal to m1g. If we take a common, so remaining is an take a LCM. So it will come as an m1 plus m2 minus m1 plus m2, minus of minus plus, so m2 upon m1 plus m2. So we took the LCM as an m1 plus m2. So into g. So already g is taken common. So m1 plus m1 minus m1 get cancelled. The remaining thing is T1 is equal to m1 m, see here, 2 m1 m2 g upon m1 plus m2. So this is an tension T1. If you want, we can find out the T2 also. So for that I will going to be draw the free body diagram. Okay, so both the answers will come the same. We can find out. So for your better understanding, okay, m2, here is an tension, downwards is an m2g. So acceleration is an upward. So that means to say that tension is an greater. So T2 minus m2g is equal to m2 into a. So T2 is equal to, so here is comes as an m2, okay, take a common, g minus a. So T2 is equal to m2 g plus a value is on how much, my dear? m1 minus m2 upon m1 plus m2 into g, right? So here we are going to take a common as an g also. So the value will come as an T2 is equal to m2g. So if you take a LCM, so m1 plus m2 plus m1 minus m2 upon m1 plus m2, plus m2 minus m2 get cancelled. Okay, the remaining thing is an T2 is equal to 2m1 m2 into g upon m1 plus m2. See, the both the value will come isn't same. So now he asked the reading. Reading is nothing but we have to divide it with a g. Okay, so reading of spring balance. Reading of spring balance is equal to T1 upon G or T2 upon G. Okay, so now any one value will take, nothing to worry. So now reading of spring balance is equal to 2m1 m2 upon m1 plus m2. Okay, this is the answer. Let's see which is the correct option. Okay, so in the question the second option is a correct option. Hope you understand, students. I am going to read the question. Three masses of 16 kg, 8 kg and 4 kg are placed in the contact as shown in the figure. If a force of 140 Newton is applied on the 4 kg mass, then the force on 16 kg will be. So we have to find out the force on 16 kg. Okay, so for that A net is equal to F net upon M net. So F net is equal to how much, my dear? It is on 140 upon M net. M net is how much? 16 plus 8 plus 4. Okay, that is equal to 140 upon, it's on total is on 28. So the answer will come as on 28 1 ja, 28 5 ja, 140. So 5 meter per second square is on A net. So now I am going to draw the free body diagram on 16 kg block. So this is an 16 kg block. Now, so here if you want to find out the tension T, so T is equal to MA, so 16 into A. So T is equal to 16 into A is came as an 5. So T is equal to 16 5 80 Newton. So 80 Newton is a correct answer. So our option is a fourth option. See here, our fourth option is a correct option. Hope you understand, students. My dear students, I am going to read the question. Using the constraint method, the relation between the acceleration of 1 and 2 is. Okay, the options are given. A1 plus A2 is equal to 0, 2A1 plus A2 is equal to 0, A1 plus 2A2 is equal to 0, 4A1 plus A2 is equal to 0. Okay, so here see only one string is there, one tension. So let it be, this side is an length of the string is an x1, so other side is an consider as an x2. So that x1 plus x2 is equal to total length of the string we can consider as an L. So x1 plus x2 is equal to L. L is a constant, yes or no? The value will not be changed, length of the string will not be changed. Okay, so total length of the string is L. Now if you differentiate on both sides, so dx1 upon dt plus dx2 upon dt is equal to, differentiation of constant is become as a 0. We know very well, yes or no? Because L is a constant value, right? So now dx1 upon dt is become as a velocity of v1, yes or no? v1 plus v2 is equal to 0. If you differentiate again with the velocity with the time, so v d1 upon dt plus v d2 dv2 upon dt is equal to 0. So dv1 upon dt is equal to a1 plus dv2 upon d2 is equal to a2. So a1 plus a2 is equal to 0. So our first option is a correct option. So hope you understand. My dear students, I am going to read the question. The constraint relation between A1, A2 and A3 is. So here the diagram is given. So he is asking what is the constraint relation in terms of acceleration. Okay. So I am going to draw the free body diagram. See here, I am going to draw the diagram here. So it is on first pulley. Now here is an one block. So this is one block. So on another side, the second side is an movable pulley. So for the movable pulley again 2 blocks is hanging, so block 2 and block 3. Okay, so now if you are considering the tensions, so 1 string 1 tension, 2 strings 2 tensions, 3 string 3 tensions, and so on. So here the first I will going to be consider as an tension T. So here also T. So T plus T, how much, my dears? 2T, right? So for the second string the tension is become as an 2T. Okay, so this side also it is an 2T. Now we know very well, so before question also we did the same thing. Okay, so if I consider is an A isolation, then obviously here is an 2A, right? So now if you write the relation, okay, according to the constraint, okay, according to constraint, so I can going to write the equation as let it be, this is an first block, second block, third block is there, right? So instead of A I can write it as an A1, A2 and A3, right? So I'll put it the names. Okay, so sum of all the length of the string must be 0, right? The accelerations actually. So when we are differentiate with the length will become as velocities again if you differentiate, then velocity become accelerations, right? So this is an A2, so this is an third block, so it is an A3, so upper one is an A1. So now we can write as an 2 here, A2 plus A3 plus 2A1 is equal to 0. So this is the constraint equation. Okay, this is the answer. So our cut option is first option. Hope you understand. So I am going to read the question, my dear students. Using the constraint equations, find the relation between A1 and A2. There are 2 blocks are given, first block and second block. We have to find out the relation. Okay, as we know that 1 string 1 tension, so T, this side is also T. So now this is an T plus T, it is become as an 2T. So this side is also it is an 2T. So I am going to write here it is an 2T. So upper string is an 2T plus 2T become as an 4T. Yes or no? 2T plus 2T is equal to 4T. So this side is also 4T. Okay, so it is an 4T. So on the first block, how many tensions are there? 4T plus 2T plus T. So total become as an 7T. Yes or no? For the second block, it is only 1 tension. So if you consider it is an A, acceleration A, so I am going to write 4T plus 2T plus T is equal to total is an 7T. So now according to constraint, so if on second block tension is T, then on first block tension is 7T, right? In the similar manner, okay, so if you want to write the acceleration, that is acceleration on second block, if acceleration on second block consider as an A2 2. Okay, then acceleration on first block become as an 7, right? Yes or no? So 7a. So now it is on first block, so we will going to give the name as an, this is an a2, so it is an a1. So now the relation is a2 plus 7a1 is equal to 0 according to the constraint, right? That is the see here, there is our answer according to the constraint equation. Okay, in the options, first option is an correct option. Hope you understand, students. My dear students, I am going to read the question. In the pulley block arrangement as shown in the figure, the relation between acceleration of a block A and B is. Okay, here the 4 options are given. Let we will going to find out. See here, I will going to draw the tensions. So one string, one tension T, this side also T. So T plus T, it's become as an 2T. So 2T, this side is also 2T. So on the A block there are 3T tension is there, on B block only T tension is there. Yes or no? So on block B, tension is T, right? Then on block A, tension is 3T. Okay, T plus 2T is equal to 3T. Now if you write the accelerations, so the acceleration consider as an A for the B block, then the acceleration on A block is 3A, right? So now the relation is an, so it is an B block, it is an A block. So now the acceleration according to the constraint equation, so according to the constraint what will happen? So 3, see here, so we are going to write here AB plus 3AA is equal to 0, right? So now AB is equal to how much, my dear? Minus 3AA. So that is our answer. So in the given option, so here is a first option is an correct answer. Hope you understand, students.